Swayam Prabha. Digital India. Educated India.
Hi, welcome to Mechanics and Control of Robotic Manipulator. You already know that this is a 8-week course. So this is the first lecture where we are going to introduce few of the important terms. So before going to see this important terms, let us actually start very formal introduction starting from the definition of robot. Okay, so this is what the overall, as you know, like most of the lectures we would be covering with several you can say internet resources and other textbooks. So I am just giving this particular you can say note here. So this particular lecture, or you call this course, is actually like containing few reference material from outside. So I am not referring then and there. That is what the condition here. So let us move to the formal course called Mechanics and Control of Robotic Manipulator. So the course name itself is saying that we are going to talk about robotic manipulator. So let us actually like talk about what is manipulation and what is manipulator and what are the types of manipulator. This is what the intention of this particular section of the course or the lecture of the course. So before that, as I already mentioned, we would be starting introducing the keyword called robot. So we will start giving a definition on robot. What is robot? So there is no, you can say, specific you call specific definition. So there is no specific definition on robot, or you call there is no clear you can say aspect on robot definition. Although this robot keyword come from robota, okay, so which is actually like a sec keyword. So which is means that it is actually like forced, or you can say slave, okay, labor. So this is what the whole basic idea. So after that, you know, like it is completely evolved and it came with a very different aspect. So we got several you call Asimov rules, although Asimov gave 3 rules, but later on it come several other rules. So in that sense, we will first talk about what is robot first of all. So we will start with a formal definition on robot. So I already said there is no specific definition, but we will see what are the things available. So we have taken one of the you can say general random house dictionary. This dictionary says that a machine, okay, robot is nothing but a machine that resembles a human being and does mechanical routine task on command. So based on this definition, what we expect something like so humanoid kind of thing, right? But this is not we are actually like expecting in this particular course. So then what would be the proper definition? So then we are actually like going and seeing what are the associations which generated all those things. So in that, one of the bigger association which is started from America, but this is what we call robotic industry associations, okay. So this particular industry association RIA, what it says, so an industrial robot, you see specifically see it's an industrial robot, is a reprogrammable multifunctional manipulator. So if you talk about anything industrial robot in the olden days, or as per the RIA, it is a multifunctional manipulator designed to move material, parts, tools, or specific or specialized devices through variable programmed motion for certain case, what for the performance of variety of tasks. So if you look at it, there are several keywords are coming. One of the main keyword which actually like so important, which is actually like what we call reprogrammed. So this reprogrammed is actually slightly different from what we conventionally use one another machine. So what another machine we call CNC machine. The CNC machine and the robot is different, mainly called reprogrammed. So then some people can call, sir, CNC also can be reprogrammed, but once the function is actually like fixed and the entity is actually like fixed, you cannot actually like easily we can make reprogrammable. So that is the basic idea, but again you can see the robot come from the CNC machine in the initial phase. So in that sense, what one of the another keyword called manipulator. So we should know what is manipulator. So these all need to be understand. Further, you can see as per the RIA, it is a multifunctional tool. or multifunctional manipulator. It is not single function. So based on this, if you keep digging or keep, you can say, going through several literature and the resources or the textbooks, you can see the history says several things. What several things says that the robot, okay, the term robot or robots are now more commonly used for certain thing, which is actually the robotic system which has a mobility. So then we have to see what is mobility and what is maneuverability. That difference definitely we need to talk. Further, in the modern days, especially in the advanced you call intelligent community and all, what they are saying that, so the robot means it is nothing but an intelligent agent, you see agent not device, physical or virtual, it can be even virtual, capable of doing a task autonomously or with guidance. So very simple example, you see a chatbot. For example, if you open several bank sites and all, you would have seen this is the site page. Either one of the corner you can see that, so may I help you. So you actually like click that, you say that what can I do for you. Then you say some command, so then it will go another. Like that it would be keep making some pre-programmed motion. Even some of the chatbots are actually like much more intelligent. You type based on your, you can say question, it start answering. So these all what in the modern days community says bot or robot. So this is one of the best examples, the chatbot. But in this particular course we are not talking that way. What we are going to see here, so robot is nothing but an electromechanical device, so or machine, simply we can call mechatronic system. So with sensors, electronics or you can say actuators and guided by computer or controller. This is what we are going to call robot in our perspective. So now you can see this robot is actually like more common in the modern community. Even you would have seen that there are several, you can say robotic competitions keep coming, robotics courses are coming, even actually like the national mission also launched several things on robotics and autonomous system. So then we can actually like have a question. So when they started, what is the prerequisite or when they use or where they use the robot. So for that we are actually like answering in one simple slide here. So when and where to use robot, so there are several thumb rules. So we are using 4 of the thumb rule which would be fit into our community, at least Indian community. But if you look at in a modern or you can say westernized community, so the first 3 Ds what was important in the sense dull, dirty, dangerous was the initial keyword brought for the robotics. Later on they have actually like brought the difficult also in the case. What that mean? If your environment is actually like dirty where the human cannot tolerate that, or it is hazardous, or it is actually like toxic, then we can actually like employ some kind of machine that to pre-programmed or reprogrammable machine. In the sense robot can be employed. Or the task is actually like very dull in the sense very much routine and it is giving a fatigueness or the dullness to the employee or the worker, then also we can use. The third thing is definitely you all agree. So if the task is dangerous, definitely we would be taking out the human. For example, you think about the nuclear installations or open cast, you can say mining. Okay. So these kind of places definitely the human is actually like in danger. So those kind of places we can actually like use. Further, what people thought about it, the task can be simple. For example, a bigger object can be pushed by a human being. This is probably easy for someone who is actually like heavy muscular, but routine people maybe it is possible, but it is actually like enormous work need to be done. In the sense it is difficult all the time. For example, carrying a 50 kilogram sack, maybe one can do it probably 1 or 2 occasions, but in a day probably 50 times he has to carry and lift it, it is probably difficult. Then we can employ. So these are the 4 Ds which are actually like initially has come, but in the modern day the 4D become actually the difficult and dangerous they combined. So they brought a keyword called dear. So although that we are going to address in the last key point, but this is actually like another modern 4D, what dull, dirty, dangerous, where the dangerous brought difficult also inside, but they brought another keyword called dear. So whenever you see keyword dear, you assume that dear means it's close to us. Yes, in certain extent, but this dear is actually like slightly different. So is the robot usage is economic benefit, then you call it as dear. So in that sense the modern 4D is actually like economic benefit also. But as per the Indian community we have to see further 2 other points. So will a human is being jobless. So if that is the case, then don't employ the robot. So that is what the case. So what that means, will the human being is actually like getting jobless, then you should not employ the robot. Similarly, the human is actually like willing to do even a difficult task, then you have to allow the human being to do, but not the robot. So in the sense, you know, like when and where to use robots, right? In the modern community, it's in the modern, in the sense the current generation, the robots no longer stick with industrial robot. Although the RIA definition says that it's an industrial robot, but in the modern days the robot is no longer stick with a industrial soft floor. It came out in a domestic, even medical or outdoor and all. So in the sense, the classification of this 4D or probably restriction on these thumb rules may not no longer exist, but we can actually like use the existing thing for at least to understand this particular course, because we are focusing on the industrial base. So you can see this. So let us move what would be our perspective as per what you call the mechanics perspective. So when you talk about mechanics, what we are seeing, it is actually like a motion system. When you are talking about the motion system, we have to define the robot in different way. What way we are going to define? So the robot or robotic device we are going to call as a effector. So what that mean? So any device or robotic device that has an effect on the environment, we call effector. Okay. So what that? So you have effect on the environment. So this is what the case. So if you have anything which is having effect on the environment, that we call effector. So now based on the effect on the environment, the effector can be further classified. That is what we are going to see. That is very much important for us. For example, this is the definition which I mentioned, that has an effect on the environment. So now what I said, the effect on the environment can create two kind of action. So one is actually like mobile, or you call mobility. So the other one is actually like, so can create manipulability. Okay. So one can create a mobility, the other one can create manipulability. For understanding that, I took a simple picture where you can see human and you can say ball are taken. So the ball and human are taken. So one picture you can see that the human standing on the ball. So now when he roll on his leg, what he can actually get? So this ball will start roll, but you can see that the effect what you are creating, the effect on the environment creating on this ball, but because of that what you are going to get, this human would be getting mobility. So this particular action what we call locomotion. So we are actually like trying to get a locomotion because of the action on the you call effector. The effector is creating effect on the environment, creating a mobility of the effector itself. Whereas the other way around, the human is lying down and he is doing the same thing. He is actually like manipulating his leg, or you can say he is moving his leg. Because of his actually like movement of the leg, what happens? This ball will get roll or it can go away. In the sense, what he is trying to do, he is trying to manipulate this ball, right. So in the sense, what we are trying to do, so we are trying to do the manipulation. So what that way, the effect on the environment causes motions of the objects around, but here the motion of the effector itself. The effector itself you call locomotion. So motions objects around call manipulation. So these are the two classification which we are doing it. One is if the effect on the environment causes motion of the effector itself, we call locomotion. The locomotive device what we call in robots, it's a mobile robot. The other one is if the effect on the environment causes motion of the objects around, which is what you call manipulation. The manipulating device what we call manipulator. Since we are talking about robotic device, so we are going to classify that as robotic manipulator. So now I hope you are clear. So what is manipulator and what is mobile robot, right? And you have clear that what is locomotion and what is manipulation. Let us move what would be covered in this particular course. So in this course what we are going to cover? We are going to cover this very specific aspect called the fixed manipulator. In the sense, what that mean? So the manipulation can be end up. So one end is fixed, the other end is actually like going to connect with the objects around, that would be manipulating the objects. Whereas the other one is actually like locomotive device, which is nothing but mobile robot. Now there may be one question can come. So what would be the role of controller? Okay. So the controller should be called as a effector. Strictly say no. So then what would be the role of the controller? The role of the controller is supposed to be to produce, okay, and say the desired effect on the environment based on the robot task. In the sense, it's supposed to make sure that the effector will get the necessary desired effect. For example, if I want to move this robot in straight line, so these 4 wheels which is going to generate the, you can say, force on the ground, or you can say the effect on the environment, create a traction. So that should actually like make in such a way that the robot will move on the straight line. So now the same way this object supposed to move maneuver, so you can actually like do it. Now one simple question will come. So this is actually like fixed manipulator and this is a mobile robot. Can I take this and put it on top of this? Yes, you can do. So that is what we call mobile manipulator, which will give dual advantage of, you can say, manipulator and mobile robot, but it will give additional limitations also that we will see at the end of this course. So what we call, you can say, mechanics of mobile manipulator, but right now what you can understand, if I put this on top, that is what you call mobile manipulator or simply called vehicle manipulator system. So now let us actually like see what would be the benefit when we start understanding this, what you call mobile manipulator or manipulator. So the manipulator is having a simple, because it is fixed. So then you can see like the environment would be, or the workspace would be confined. So you can always actually like have a confined workspace, and then because of the confined workspace, even pre-programmed motion can be generated, but in this case it is not so easy. Okay. So that is one important thing. We will see the difference in detail. Okay. So let us actually like move further. So what would be our perspective of this particular course? So we would be talking about robotic manipulator, that is nothing but a software controlled mechanical device that uses sensors to guide one or more end effectors through programmed motion in a given workspace in order to manipulate physical object. In that sense, the mechanical manipulator would not come as robotic system. Okay. For example, I have a mechanical motion. Okay. So this mechanical motion would not be come under. It's supposed to be electrically connected with some kind of controlled device. So then only you can call as robotic system. Okay. So that is what we are trying. So now we can see, we will bring back what is manipulation. So what is manipulation? If the effect on the environment causes motion of the object around. So now you can see like, so this is not a new thing. What is actually like come? The robotic manipulator is not new thing. It started in 1960, it matured in 80s and 90s, it start ruling the world. So then what the generation changed? So now the generation has actually changed from this, where this is the conventional robotic manipulator, which would be having gravity balance done with the parallelogram mechanism, counterweight and all the actuator at the bottom and the controlling station all in the bottom. You can see even a small 1 kg payload, it would be having a very heavy structure. Then people thought about, can we use cable operated? So then they call compliant robot, where everything would be connected with the cable, which is actually like easy for us to control and as well as maintain the stability, in the sense gravity balance. So this is the second generation from the conventional rigid bodies, which is actually like very massive bodies, to some kind of, you can say, compromised one. But what additionally done in the current perspective, we are in the arena or area of, we call cobots. What that means, you can see the actuators are actually like simple disc type. In addition to that, these robots are actually like gravity balance done with a simple, you can say, spring system or some kind of cam and, you can say, you call cable operated. Further, what advantage, these all the system would be having a sensor. When you hit this, so this will stop and react later. So in the sense, this can be easily applied for the human interacted environment, we call cobot scenario. So right now we are in the collaborative environment, we call cobot. Okay. So this is what we are actually like in the current perspective. We are going to study about all this, because we are going to study about the mechanics. So we can see how this is actually like different from this. All those things we can actually like study, why it is actually like better, that also we can see. So let us actually like move further. So we know now what is manipulator. Now we need to define manipulator, already we did. So what additionally you can see how we can classify this into number of things. So one of the easiest way we can classify, for classification I took this particular, you call images. So what images I have taken two of the tennis shot, one is actually like backhand, the other one is forehand. So what one can see, so the person who is actually like the same person, so he is actually like you can see the serve is actually like taking it at this end effector, which is nothing but the racket of the tennis racket. So it is supposed to take this ball. So for that he need more power. For that time what he is doing, this end effector to the base, because he is grounded. So this is connected with two serial chain connected in a parallel way. So now what it is giving? It is giving a closed loop. Okay. Whereas when he want to take a side court shots, the end effector is still the racket, but what is doing is actually like connected in series, in the sense this is grounded, but he is actually like reaching through series connection. So these are the two difference. So one is actually like open, so the other one is closed. So the closed, which is what we call parallel manipulator. Even you can take our own example. So for example, now you want to take a 5 kilo, you can say, or 5 liter cooker from the stove. So you will not take one handed because it is very heavy, right? You would use a two hand. Why? Because you can actually like manipulate, or you can actually like hold in better way. So similarly you can see like when you actually like put your head, some you can say sad occasions will actually like keep your head like this, right, when you actually like put it. So that time actually like what you actually like make, you make a closed loop. So these are the cases. So now based on that background you can see like one additional aspect will bring two such case. One is serial manipulator, the other one is parallel manipulator. What serial manipulator? So the bodies are arranged in series, okay, it make open chain, okay, where the end effector to the base is in a open chain. So that is what we call, so it is open chain manipulator, okay. This is actually like parallel chain. For example, this Airbus cabin supposed to provide or supposed to get required motion, that is controlled in three, you can say, legs here and additional 3 legs. So totally you can see like 6 legs are providing the motion. But what you can see, this is grounded and this is mobile platform that is connected with several serial legs, which makes actually like several closed loop. What that mean? This is actually like giving a closed loop chain. So which is actually like what you call parallel connection in the sense. So for example, you take your serial chain and you connected with another serial chain, what happened? This would be making a closed loop that will give, you can say, high payload, but it would be restricted to the smaller workspace. So that is what we are going to see as types. So one is open chain, so the other one is actually like closed loop. So open chain manipulator we call serial, so the closed loop we call parallel. It can be combined. For example, you can see the parallel connected with the serial. So the hexapod steward platform connected with the SCARA robot, we will see what exactly that in detail. So this will give a hybrid combine, in the sense combined manipulator. This is actually like you can see it is giving a closed loop, but this is actually like giving a open loop chain. So this is what the background. So what is the classification? So further I want to actually like give the open chain will give a larger workspace that you would have already seen. The tennis player open his hand because he will get larger workspace. Whereas when you want to take high load, he would be closed. What that mean? Your body would be actually like make stiffer your connection. The end effector would be rigid firm, and you can act as a faster and you can make a precise movement. So that is what the case. You can see both are actually like industrial robot, but this is having a several, you can say, closed loop, but this is a open. This is the basic difference. But when we actually like see the other way around, the serial robot, we know like the one of the thing is fixed base, but the links and joints connected sequentially and ending in a end effector. Whereas the parallel robot, more than one loop, end effector connected with multiple serial chain. You can see, right. So there are 6 actuators, but you can see like this is connected in parallel way, but this is actually like open, which is a serial chain. So now we will actually like add additional. So what additional? So the manipulator further can be classified based on the rigidityness, or you can say based on the, you can say, construction. It can be rigid link where this is actually like at any given point. So distance between 2 points would be not going to change. So in that case what you call the link would be rigid. So the rigid link manipulator is one classification. So the other case, the link can be flexible. So for example, time to time it is getting changed. For example, snake, or you can say some kind of flexible member, for example pneumatic muscle and all. So in that case, this is actually like what you call something a flexible link manipulator. So now you got some kind of idea. So only one thing I want to actually like add here, so the serial robot would be having 1D of systems, okay. So all the joints which is having 1 degree of freedom. So we would be seeing what is degrees of freedom in the next lecture, but this will have actually like open, and one member which should be connected with another member is only one motion provision, where parallel robot would be having more flexibility, okay. So that is what the case. So with that I actually like end this particular lecture. So what we have seen, so what is manipulator and what are the types. So the next lecture we would be seeing the robot mechanics, in specific manipulator mechanics. We will start with the degree of freedom and we will end with one of the basic entity in robotic manipulator called robot kinematics. So until then, see you, bye, take care, see you then.